All right, so today we're going to review 3 of our kinds of factoring. So if we look at example number 1 there, does anybody remember what kind of factoring that one would be? GCF, yes. So GCF stands for greatest common factor. So what you want to do is you want to try to find the largest number that goes into your coefficients. And then as far as the exponents go, the smallest exponent that is there is part of your GCF. So if we look at our numbers here, we've got a 6 and a 15. So what's going to be the largest number that goes into 6 and 15? 3. Taking a look at our x's, both terms have an x. The lowest exponent between those would be a 2, so 3x squared. Both terms also have a y, so that's going to be part of our GCF. Lowest exponent on the y's is a 2. So 3x squared, y squared is our GCF. How do we find the stuff that goes in the rest of those parentheses? Say that? Yeah. Yep. So we divide by our GCF. So you actually divide the numbers, you subtract those exponents. So 6 divided by 3 gives us a 2. 3 minus 2 gives us an x to the first. And since those y's are the same exact exponents, they just cancel each other out. And then minus 15 divided by 3 gives me a 5. This time our x's cancel, so then we're left with y to the third. And that's our GCF. We could check that by taking your GCF out in front. You could distribute it through, and you would get the same answer that we started with. Second one, what kind of factoring do we have there? Does anybody remember? Yes, dots. Difference of 2 squares. So difference means it's got to be a subtraction. So they like to throw people off by putting a plus sign in there, and then you see the 2 perfect squares, and you're like, oh, it's dots. It's not dots. It has to be subtraction. So for our dots factoring, we set up 2 sets of parentheses for it. And then you take the square root of the term. So our first term here, when I take the square root of it, we would get 6x and 6x, so that goes in the first spot. Signs are always different, so one's negative, one's positive. Then if we take a square root of that last term, what do we get? 5y squared. So there's our final answer for that. And then our last kind that we're going to review today, that third one, what is that last kind? Trinomial. Now I know some other teachers have different tricks along the way. If your little tricks work for you, go for it. I generally have a tendency to do guess and check purely with these ones because that's the way that I was always taught. So remember with trinomial, it's 2 sets of parentheses, just like with your dots. The only time it's not 2 sets of parentheses is when you're doing your GCF factoring there. So you're looking for what multiplies to the first term and the last term. And then it's got to add to give you your middle term. So it's multiply for the 2 outside ones, adds for that middle one. X squared always gets broken apart into x and x. X times x gives us x squared. So we got to figure out what multiplies to give us negative 20, but would add to give us a negative 8. Negative 10 and positive 2. So negative 10 times 2 does give us that negative 20. Remember, to get that middle term, what you end up doing is you multiply these 2, and then you multiply those outside 2. So when I add those 2 together, that's where our negative 8x comes from. I have a tendency to refer to that as big smile, little smile. All right, let's take a look at that third one. Or second one, I mean. Second one there. A lot of people get scared by that one because it's got 2 letters, but there's no reason to get scared by it. So our x squared to start off with, still going to be x and x. We end here with a 16y squared. Now, because that's positive, remember your signs will be the same when we factor. The negative in front of that 10 means your signs are going to both be negative. Because remember, negative times negative would give us that positive for the end. So we got to figure out what multiplies for 16, but we'll add to give us 10. 8 and 2. And because it's got this y squared here in our last term, that means it's going to be 8y and 2y. And when you do that little smile, big smile to check, that's where your xy comes into play, because negative 8y times x would be negative 8xy. So that's how we get both of them together. And then x times that negative 2y gives us negative 2xy. And then our third one there, starting off with a 2x squared. So that means we have to do 2x and then 1x. That's our only way to get a 2x squared. So then we got that 7 in the middle, and a lot of people always tell me, okay, well, it multiplies 7 is 7 times 1, but that doesn't give me a 13. You got to remember that 2 is important. I want to put the 7 here because then that 7, remember, gets multiplied by that 2x, which makes it a 14. So I'd want it to be positive, and over there I'd want to subtract the 1 from it, because that would give me a negative 1x. So 14 minus 1x gives me the 13x. So if you got that number out in front, that does always affect the way it's going to get you your middle term. So let's practice these a little bit more, only I kind of threw some twists into some of them. So looking at GCF, but going a little bit harder this time, your GCF is a binomial. So if we look at letter A here, the thing they have in common is that 2x plus 1. So that is going to be your GCF. So just like before, I'm going to still take my GCF and I'm going to put it out in front, but since it's 2 terms this time, I have to put it in parentheses. Up above in that other example, it was just 1 term, so I didn't have to put it in parentheses. This one, 2 terms. To get the other stuff in the parentheses, it's just like up above. I would divide by my GCF. So I would divide by the 2x plus 1. And when I do that, those end up canceling. So we're left with x plus 7. So that's going to end up being our other factor. So let's try it again. For letter B, what would our GCF be? The x minus 2. And I'm going to go cross those out, because remember, when I divide by it, it makes that x minus 2 go away. So we would be left with that 5x and then the minus 4. Letter C, what's our GCF there? X minus 7. This time when we take out our GCF, what we're left with is we're left with this x plus 5 plus this x plus 1. So we're going to combine our like terms. X plus x gives me 2x. 5 plus 1 gives me a 6. So 2x plus 6. So then D is going to be similar to C, our GCF here. Would be that x plus 4, that's with both of them. The only difference this time is we're subtracting. So remember to subtract each part. 2x minus 1x gives us a 1x. So then 8 minus negative 2 makes that a plus 10. So looking at our dots again, we got a couple more complicated ones here. The pattern, though, for when we're factoring using dots is it's the square root of each term, which make one positive, one negative. So a squared, take the square root of it, you get a. B squared, you take the square root of it, you get b. And one's plus, one's minus. So that first one's really not too bad. What's the square root of 4x squared? 2x. So that's what we will start with. So we got 2x and 2x. One's plus, one's minus. Square root of the second one. 5y to the third. Good. There you go. Now for number 2, a lot of people tend to get freaked out because you got the fraction there, but fractions are our friends. That's why they both start with FR. So if we look at the top, let's look at each piece. Is 36 perfect square? Yes. Is 81 a perfect square? Yes. So the whole fraction's a perfect square then. If each part is, the whole thing is. So if we take the square root, what's the square root of 36? And then the square root of 81? So it becomes 6 over 9. And then we got AB to the 5th. Then over here, 6 over 9, AB to the 5th. I didn't give myself very much room. Oh well. So then square root of the second part. 7 y6z to the second. 7y6z squared. And then that third example, is that even a dots problem? Yeah. It's got an even exponent, so that is a perfect square. And then number 9 is a perfect square. So when I take the square root of this, all that does is it just cancels out my exponent there. So that means the first part of each of my factors, when I go to factor, it would be the a plus 2. And then we got our minus 3 plus 3 from the 9. Now is that simplified as far as it can go? Nope. I got some numbers I can combine in there, so I have to do that. I got to combine my 2's and my 3's. That turns into a minus 1 and then a plus 5. Now that one's done. You've always got to remember to simplify. All right, let's look at our trinomials here. There's no real rule to follow. A lot of times, as I said, it's just guess and check. So if we take a look at our first example here, even though it's x to the 4th, it's still factorable. You just divide that exponent by 2, so it would start off with x squared and x squared. And then all the rest of it is the same as our other trinomial. So you're looking for what multiplies to give us negative 40, but would add to give you a 3. So what would multiply to give us negative 40, add for 3? 8 and 5. Which one's my positive? Yeah, positive 8. And then minus 5. And again, that squared term in the middle comes from when you do your little smile and your big smile. So here this would be 8x squared. This would be negative 5x squared. Add those together. There's your 3x squared. So second one, this time we start off with an x squared. So we're going to have an x and an x in there. So what's going to multiply for 36 but add to give us a negative 13? 9 and 4. So because it's got that y squared at the end, that means it's actually going to be 9y and 4y. So minus 9y and then minus 4y. All right, take a second. I want you to try the third one. Just try. How do we do? Did you guys get it? Yes. All right. 3 more. So when you look at these last 3, well, at least my first instinct would always be, let me put my squared term first and then let me try to factor it. But you can't do that because if I move my squared term first, then I would end up with a negative x squared, and you can't factor the negative x squared. So you want to leave the order the way it is. So it's really still the same process as what we were doing before with our trinomials. It does get a little confusing because things are backwards from the way we're used to it, but I start with my x squared still, and I break that apart like we normally would. That's still x and x. I just put it second this time. I'm then still going to go to my number next. I got to figure out what multiplies for 36, but would give me a 5 in the middle. 9 and 4. So now here's the tricky part. We got to figure out where our signs are going to be. One's going to be positive, one's going to be negative. To get this negative 5 right here in the middle, that means I want this 9 to be negative. This 9 would end up being multiplied by that x, so that's going to have to be the one that's negative, so that when I multiply them, I get negative 9x. That one would have to be positive, because then when I multiply these two, I would get my positive 4x. So there's our negative 5. All right, let's try it again for number 5 there. So again, I start off with my x's. I put those last. We're looking for it multiplies to 14, but would give us a 5 in the middle. Multiplies to 14, gives us a 5 in the middle. 7 and 2. I want it to be a positive 5, which means the 7 has to be my positive. It would be times that x there, so I'm going to make that one my positive. And then this one's going to be my negative. All right, last one there, number 6. So I put my a's first. Positive at the end, a negative sign in the middle tells me they're both going to be negative, so that's at least a little bit easier than those other two that we had. We just have to think now of factors of 72 that add to 22. Do you remember the trick of how to find factors in your calculator? So under the y equals, if you type in whatever you're trying to find factors of, so in this case 72, so I do 72 divided by x. Look at my table, there's all my factors. So 1 times 72, 2 times 36, 3 times 24. Which ones are going to add to 22? 4 and 18. And there we go.